Inventor Nastran is a simulation module that comes with the Autodesk Product Design and Manufacturing Collection. So with this, you're able to do a couple of analyses, and when you do open up Nastran, to open up Inventor Nastran, go to Environment, select Autodesk Inventor Nastran over there, and you'll see that this Autodesk Inventor Nastran ribbon pops up. Now, what I'm going to show you today is buckling, or how to get the critical buckling value. So the first things first is we need to go change the analysis to a buckling analysis. So under your type, select linear buckling or non-linear buckling. We're going to do linear buckling and just give it a name so you can easily identify what analysis you're doing. Next, we are going to go create a mesh, or we're going to go put our mesh in. So go to mesh settings, and here you can see the mesh settings is 56 millimeters. Now this hole over here is about 7 or 8 millimeters. So I'm going to go put this at 15. And let's go and generate the mesh. Now, what we're actually doing is we're going to be idealizing the solid over here. You can do either a linear, or you can also do a surface element as well for your idealization. Okay, so it's meshed it over there. Next, we're going to do is put our constraints in, and I'm going to put a constraint, sorry, at the bottom over here. And to see what the constraint looks like, and click on those little glasses over there, you'll see that it isn't able to translate in the X, Y, and Z directions. It's not able to rotate in the X, Y, and Z either. Now, just to take a look at the density, I can put that up, and you'll see it will show a lot more arrows over there. And okay, it's just taking a bit of a while. And we seem to be having some graphics problems here. Okay, cool. Try again. Okay, I'm going to click on OK, and it's showing me where my constraint is over there. Now let's go put in some loads. So the loads I'm going to go put on the top two slots over here, and those loads are going to be sitting on these two surfaces over here. See what's on the edge. Okay, so on that surface and on that surface over there, you'll see the selected entities, phase 661 and 667. It's going to be a force. I want it to be the total force, and if you look at the arrows, positive Z is going up, so I want it minus 35,000, and click on OK. Okay, you can see those two arrows pointing down over there. Okay, so that's basically all I need for my analysis or my simulation to get that critical value for buckling. And then we click on run. Oh, before I do that, my apologies, you need to make sure that you've got the correct material on. So go to the materials. The material I've got at the moment is, let's just go choose mild steel. Actually, no, let's go choose S355. Okay. Okay, there we go. So now we've got a material, we've got our constraints, our fixed constraints, we've got our loads as well. And then we click on run. Once the analysis or simulation is complete, we can go to the results and see exactly what's going on here. So if I right click on the results and click on edit, you will see the plot dialog box come up. Now, what we want to take a look at is you'll see under subcase, you'll see a mode 1 eigenvalue 0.93. Now, what that number is the number that you multiply the force that you applied to get the buckling load. So basically, get the critical buckling value. So it's going to buckle at 35,000 times 0.93. If you want to look at the mode of when it's buckling, select the mode case 1, and we can go through to, under result data, we can go to displacement. And from displacement, we can take a look at the display. And it'll give you a visual representation on the mode of the profile buckling. So in this demonstration, what I've shown you just quickly how to put on your loads, how to put on your constraints, and then also to get your eigenvalue, which is the multiplication, is the value that you multiply your load by to see when when it is actually going to buckle, as well as putting onto displacement. You can see then the mode that Autodesk Nastran or Inventor Nastran gives you. Okay, great. Thank you very much for watching.